Hey everybody! In this video, I'm going to give you an example of how to transform a function when given a graph and not an equation. So what you have here on your screen is a random piecewise function. It's not your standard parabola or line. It's kind of this arbitrary random shape. We're going to call this entire graph f, or f of x. That's just the name of the function. And what you'll see down here is different rules for how you're going to transform function f. Okay, so this looks like it could be an equation, but I want you to think of each of these more like a rule. And this rule says to get a new function g of x, you're going to take f and do these two things to it, for this problem at least. The very first step you want to take when doing a problem like this is just to identify what each of the transformations means. What does it do to the function? So what does the plus 2 do? What does the minus 3 do? I want you to look at each of these numbers as a separate rule, which is kind of different than how we normally look at something like this. So first thing we're going to look at is the plus 2. First, you want to ask yourself, is this going to affect the x coordinates or the y coordinates? Meaning, is it a horizontal or a vertical transformation? And anything that is directly attached to the x, it's x plus 2, is going to affect the x coordinates. It's going to affect the x coordinates, which makes it a horizontal transformation of some sort. Okay, versus if it's attached to the function as a whole. So the function as a whole, the outputs are f of x. That's this. This is the function as a whole. The minus 3 is being applied to all of that. That's going to apply to the y coordinates, which means this is going to be a vertical transformation, up or down, because that's what way y goes. Okay, that's very intuitive. If it's attached to the x directly, it affects the x. If it's attached to f of x, it affects the y. Okay. From there, you want to see what kind of transformation it is going to be. Is it a reflection? Is it a stretch, a compression, or a translation? And anytime you have something being added or subtracted, those are both translations. So the first one is a horizontal translation. The second one will be a vertical translation, because they're being added or subtracted, not multiplied. Okay, and in this case, okay, if we have a vertical translation of minus 3, that does exactly what you think it's going to do. That is going to move the whole graph down 3 units. Okay, the x transformations always do the opposite of how they appear because our function has y isolated, not x. So it looks like this is going to go to the right 2 units. It's actually going to go to the left 2 units. That's only for x transformations, will kind of operate the opposite of how they appear. Okay, so with that said, in order to get graph g of x, that's what you're going to do to graph f of x. You're going to move it left 2 units and down 3 units. So I'm going to take this entire shape here, and I'm going to move it to the left 2 units and down 3 units. So our new function, if I were to just like sketch out what it was going to look like, would look something like this. And that's not perfect. You're going to do it perfectly now. Okay. Since it's kind of hard to take the whole function and move it, what you're going to do is you're going to move each point in that direction. So I would start with -4, 0. I would move it to the left 2 units, which would make my new x coordinate -6. And then I'll move it down 1, 2, 3 units. So my new point will go from here to here. Okay. In order to keep track of that, I'm actually going to make a table of the original points. And then I'm going to write the new point, the transform point, whatever you want to call it. So the original point was -4, 0. Then it moved to the left 2 units. So the new x coordinate now is at -6. So the left only affects the x. The down, what was it, down 3 units? Yeah, that's going to affect the y coordinate. So my new y coordinate is now at -3. So when I graph this function, -4, 0 moves to this new point. And I'm going to repeat this for each of the points on the graph. So my next point right here is -3, -2. If I move that to the left 2 units, that's going to affect the x. So -3, -4, now it's -5. And if I move it down 3 units, it starts at -2, then it would go to -3, -4, -5. And you're going to do this for each of the points on the graph. So I'm going to start by just filling out the left side of this table here and get all the points that are labeled. So our next point we're going to transform is -1, -2. Then to, nope, I missed one. Then it's going to be the origin, 0, 0. Then it's going to be 2, 3. And then it's going to be 5, 0. You don't have to do every single point on the graph, but I think the label ones will help us get a picture of what this is going to look like when we plot them. I'm going to pause the video for a second, and I'm going to move all of these points left 2 units and down 3 units, and then I'll come back with what it should look like. Try this on your own. Okay, if done correctly, these are the points you should have. Moved left 2 units, which affects the x-coordinate, down 3 units would affect the y-coordinate. And now all you have to do to transform the whole graph is to plot all these new points. Okay, it's much easier than taking the graph and just trying to like scoot it over. You have a more precise graph if you do it one by one. So that's what I'm going to do right now is I'm going to plot all these points. The first point being -6, -3. So -6, -3 is my first point. Go ahead and plot all your points. I'm going to pause the video. When I come back, you should have the same things plotted as me. Okay, here are all my points plotted. Now I'm just going to connect the points so I can see what this shape looks like. And if done correctly, it should look exactly like your original shape, but it moved to the left 2 units and down 3 units, which it does, and that's why I know I've done it correctly. It's just a more precise way to do that. Okay, sometimes the shape will change, like I could do a reflection over an axis, or I can compress or stretch it. In this case, all it did was slid around the graph, which is what a translation is. Okay, so any of the problems you're given, the very first thing you're going to do is just interpret it. So it says number 2, to get h of x, you're going to take the function f, which is the original function that we looked at before, and you're going to apply this one transformation to it, and you're going to take a moment to think about what that transformation is. And I'm going to label it first. So this is applied to the x. That means this is going to affect the x coordinates. I'm going to abbreviate that. Okay, if it affects the x coordinates, it's going to be some sort of horizontal transformation. In this case, it's a multiplied factor, so that's either going to be a stretch or compression. Okay, now remember, anything that's applied to the x will do the opposite operation. So this looks like I would multiply all the x's by 2. I would actually divide the x's by 2. X coordinates by 2. So if you take all the x coordinates and you divide them by 2, I'll give you an example. Let's say the x coordinate, I'll take this point right here, was -4. Now you divide that by 2, you're going to be at -2. If you take 5 and divide that by 2, you're going to be at 2.5. So what's going to happen to the function is it's going to like go like this, like squeeze into the middle, which means this is a horizontal compression. It's going to squish horizontally, if you will. So this is going to be a horizontal compression, getting smaller, not larger. So if done correctly, this graph should look very similar to our original graph of f, but it's going to compress horizontally by dividing all the x coordinates by 2. So it's going to look, I don't know, something like this. Very similar to the original, not a great picture, but it's going to be squished. We're going to look at the next 2 as well and just kind of talk about what the transformations are. And then I'm going to leave you to try graphing them all on your own. See how that goes. Next one, there's actually 2 transformations here. There's the negative and there's the 3/2. And I know that -3/2 is one number, but I like to look at these as 2, because anytime you take a number and multiply it, which is what this is doing, to the original function, a negative number is going to be a reflection. And then you have to ask yourself, is it reflecting the x or the y values and over which axis? So in this particular problem, you are taking -3/2 and multiplying it by the function as a whole, which f of x is kind of like saying y. So you're multiplying all of the y values or the y coordinates, and you're taking all those y values and multiplying them by negative. Which means if your y value was like 6 and you multiply 6 by negative, it's now negative 6. If it was 2, it's now negative 2. So which axis are we reflecting over? So this is a reflection over the x-axis, if done correctly. The 3/2 then will do kind of the same thing. You're still multiplying the y values are being multiplied by 3/2. So if you're taking the y values and multiplying by 3/2, that's the same as multiplying by 1.5. So if I take a y value that's 6 and I multiply that by 1.5, that 6 is going to get bigger. Multiply that by 1.5, we're going to be at 9 now. So what this is going to do, if it's multiplying the y values, that's going up and down. This is a vertical stretch. Cool. And this is another one you can try on your own to graph, but that is how you would do it. Last but not least, you have two transformations on this one. You have the 3 and the -1, both applied to x. The -1 is directly attached to the x. It adds or subtracts. So this has to be a horizontal translation. If it adds or subtracts, that means it slides left or right. And it looks like it would go left because it's x -1, but we know all x transformations do the opposite operation. So this is actually going to go to the right 1 unit for all of the points. So it's going to slide over this way 1 unit. That was supposed to be an arrow. Okay, the 3. The 3 is not being multiplied directly to the x. The 3 is being multiplied to f. And f is how you write the outputs. So this is going to affect the y values. If it affects the y values, that makes this vertical. And since it's being multiplied, you're taking all the y values and multiplying them by 3. Y transformations do exactly what you think. So that means it's going to stretch all the y values by a factor of 3. Okay, so you're going to take the y value. If the y value is 2, you multiply by 3. Your y value is now 6. So it's going to get taller. I want you to try graphing each of these 3 on your own. Okay, and if you have any questions, please come and see me. Otherwise, I would use this strategy. Start with the original point, do the transformations we just went over. So if it's a vertical stretch by a factor of 3, multiply the y value by 3, and you can get the new points. That's all I have for now. Have a good rest of your day.